Hey everybody, and this is Unit 5B, Video 4, and it's the last set of identities. It's our double angles for our sine and cosine functions. Let's get started. Alright, so a double angle implies that we're looking for 2 times an angle. So if I were to use the cosine of 2 times A, I'm asking for 2 times whatever angle A is. Maybe it's 30 degrees, so that's 2 times 30. Maybe it's 75 degrees, so it's 2 times 75. Whatever we're looking for, we're trying to double it. So that's why we call it our double angles. Well, doubling it really just means that we're adding it together twice. So this brings us back to our sum of our cosine. So we did this one before. And this will give us the cosine of the first times the cosine of the second minus the sine of the first times the sine of the second. It just so happens that the first and second angle here, instead of having a B, is another A. So if I combine these together using multiplication, I get cosine squared of angle A minus the sine squared of angle A. And that is our double angle identity for cosine. Well, going back to our Pythagorean theorem, I had sine squared of an angle plus cosine squared of an angle equals 1. And we knew that if we subtracted one of them over to the other side, we ended up with 2 extra equivalent bonuses here. So I had sine squared 1 minus cosine squared of A. If I were to replace my cosine squared of A in my identity up here with this 1 minus sine squared, I would get a second identity that is exactly the same. It's still the double angle. You will see these on your district assessments at the end of the semester, possibly on a quarter assessment, that kind of thing. So it's important that you know they all actually equal the same thing. So this is would turn into 1 minus 2 sine squared of the angle. And if I were to replace the sine squared with the 1 minus cosine squared, I would end up with 2 cosine squared of the angle minus 1. So they're all the same, and that's why when we had our identities chapter, we could always turn one of these into the other. It's because they all actually represented the cosine of a double angle. So we're going to go ahead and do an example of using this double angle. Sorry about that. And I'll go ahead and show you that now. So let's say we have the sine of angle T and it equaled 2 over 5, and we know that this was in quadrant 2. So because I'm looking for a double angle, I only need one angle to get started with this. But I do need 2 values. I need the sine and the cosine. So I have my sine, and I'm going to draw my triangle in order to find the cosine of this. So we'll do the Pythagorean theorem. 25 equals 2 squared plus something squared. So 25 equals 4 plus x squared. 21 equals x squared. So this is going to be the negative square root of 21 because it moved in the left direction, which means my extra information here is that my cosine of angle T is going to be negative root 21 over 5. So as I go ahead to use my double angle formula, and I'm going to use the cosine of 2 times t is going to be equal to cosine squared of t minus sine squared of t. So what is cosine of t? Well, it's negative root 21 over 5, and I'm going to square it, minus the 2/5, and I'm going to square that as well. So once you write out your formula, cosine squared of t minus sine squared of t, and you have the 2 values that you need, you replace them in the formula and then simplify. So the square root of 21 squared, and it's negative, will become positive 21 over 25. Square this one and you get 4 over 25. We can subtract them for a final answer of 17 over 25. And that is the double angle for t. Let's go ahead and try the sine function. So for our sine function, once again going to go ahead and figure out how they came up with it. And if I want the sine of 2 times an angle, then I really want the sine of angle plus an angle. So using the sum formula here, I get the sine of angle A times the cosine of angle A plus the sine of angle A times the cosine of angle A. Remember, if these were different angles A and B, this is not how it would look. I would have B's in place in two positions, but because the angle is the same, it all has this angle A. But if I have sine of A cosine of A plus sine of A cosine of A, I technically have 2 sine of A cosine of A. Now, because nothing is squared here, I really don't have the option to replace them with anything, except if I wanted secants and cosecants, but I don't. So there's no extra ones to memorize for your sine because nothing's squared, so I don't have anything to work with. So this is my double angle formula for sine. You need to know that one as well. So let's do one example for that. So let's suppose I give you that the cosine of an angle is equal to -4/7 and we are in quadrant 3. So I want to find the cosine of 2 times this angle. Well, in order to use the cosine of 2 times this angle, I need the cosine and the sine of the angle. I have the cosine, so we're going to draw our triangle and we're going to find, the sine of the angle. So doing the Pythagorean theorem, -4 quantity squared plus whatever my y value is going to be squared equals 49. This is a 16, so we'll subtract that, and y squared equals 33. So this is -√33. So I'm going to add that to my information. And I have that the sine of this angle is -√33/7. Once I know my two pieces of information about the exact same angle, I can use my formula, which is, I was wanting to find the sine here, so let's change that. I want to find the sine of 2 times the angle. We already found the cosine. That looks strange. So I want 2 times the sine of the angle, cosine of the angle, and that is my formula, 2 sine cosine, and I just have to substitute in the two values into those positions. So 2 times -√33/7 and -4/7. I can then just multiply my numerators and my denominators, keeping in mind that 2 is actually in the numerator. So my denominator is going to be a 49. It's going to turn positive because I have a negative and a negative, and it's going to be 8 square root of 33. Numbers on the inside stay on the inside, and numbers on the outside stay on the outside. 8 and 49 do not reduce, so this is my final answer. So you do need to memorize the two formulas and be comfortable with the fact that the cosine of twice an angle actually can turn into 2 other freebie identities. But that's it. Go ahead and get started.